the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on factors that affect chemical equilibrium. Last time, we talked about reversible and irreversible reactions. We learned that reversible reactions are able to proceed in both a forward and backward direction, while irreversible reactions are only able to proceed forwards. We also learned about chemical equilibrium and dynamic equilibrium. In today's lesson, we are going to state Le Chatelier's principle, which is used by chemists to predict the effect of a change in conditions on a chemical equilibrium. We will also use this principle to explain the effect of changes in temperature. If you are ready, students, let us get started. As you know from our last lesson, equilibrium is the state of a chemical system in which the rates of the forward and reverse reactions are equal. Dynamic equilibrium means that the reaction does not stop. Both the forward and backwards reactions continue at equal rates. A system remains in a state of chemical equilibrium if there is no change in the external conditions that disturb the equilibrium. However, if the external conditions, such as the temperature, pressure, concentration, or a number of other factors do change, the point of equilibrium can be affected. A principle was created that states how a system at equilibrium adjusts itself to any of these changes. It was created by French chemist Henri Louis Le Chatelier in 1888 and is called Le Chatelier's principle. Le Chatelier stated that if a stress is applied to a system in equilibrium, the system will respond in such a way to counteract the stress. The stress could be a change in temperature, concentration, or pressure. Today, we are going to focus on changes in temperature. We will learn about changes in concentration or pressure in our next lesson. The effect that temperature changes have on equilibrium depends on whether the reaction is exothermic or endothermic. An increase in the temperature of a system will favor an endothermic reaction. A decrease in temperature favors an exothermic reaction. Students, let us look at an example. Consider the reaction of water and carbon monoxide that produces hydrogen and carbon dioxide. For this equation, the enthalpy, or change in H, is equal to negative 41 kilojoules. Enthalpy is a measure of the total energy of a thermodynamic system. If the enthalpy is greater than 0, we can tell that the reaction is endothermic. If the enthalpy is less than 0, such as with this equation, we can tell that the reaction is exothermic. Since the reaction is exothermic, if the temperature is increased, the system will shift to the left. If the temperature is decreased, the system will shift to the right, and a high yield of products is obtained. Students, let us do an activity. When equilibrium is shifted to the right, what happens to the concentration of reactants and products? Do they increase or do they decrease? Explain.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. When equilibrium is shifted to the right, the concentration of the reactants decreases, and the concentration or amount of product increases. If that is the answer you have, then you are correct. Great job! Let us continue with our lesson with another activity, so we can practice what we have just learned. Students, name 2 properties that can be used to determine whether a chemical system is in equilibrium.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. Let us answer this question together. One property is that at the state of equilibrium, the rates of the forward and reverse reactions are equal. A second property is that there is no change in the concentration of reactants and products. However, keep in mind that this does not mean that the concentration of the reactants and products are equal. Let us try one more activity. Look at this equilibrium system. Is it endothermic or exothermic? How do you know? How would the position of the equilibrium change if the temperature increased?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. If you said this equilibrium system is endothermic, you are correct. We know this because the enthalpy is greater than 0. You are also correct to say that if the temperature of this system increased, the equilibrium would shift to the right. Good work, students! In today's lesson, we learned about Le Chatelier's principle. This principle states that if a stress is applied to a system in equilibrium, the system will respond in such a way to counteract the stress. We learned that the stress could be a change in temperature, concentration, or pressure. We also learned how to tell if an equation is endothermic or exothermic based on its enthalpy, and we learned how to use Le Chatelier's principle to explain the effect that change in temperature has on equilibrium. This is all the time we have for today's lesson. Until next time, thank you, teacher. Thank you, students.